This is the beginning of Unit 7, our unit on polynomials. So for day 1, we're just going to classify polynomials and we're going to be simplifying some polynomials as well. We have done this in earlier units. We're just going to start looking at different aspects of these polynomials. All right, so just a reminder, when we are talking about terms, we are talking about things that are being separated by adding or subtracting. So the whole unit, 5x squared here, is separated from 2y by that addition sign. So 5x squared is a term, also 2y is a term. Also over here, 7 is a term. It's being separated from 2y by, right now, a subtraction sign, but of course we know that minus 7 is the same as plus negative 7. So that's just a side note, that negative is glued to that 7. Okay, so a term is any number or a variable or numbers and variables being multiplied together at one time. And again, they are separated by plus or minus, or also the equal sign if you're looking at a whole equation. Okay, so a polynomial, poly means many, and nomial, we're naming something. So it's just an expression that has many terms. In those terms, all of the variables have whole number exponents. So you'll be happy to know we're not going to have anything to the 1/2 power, so that means we have no square roots, we have no 1/3 powers, we have no cube roots. So we have exponents that are like 1 or 2 or possibly 3 or 4. All right, so we also will not have any negative exponents, and we're not going to have any variables in our denominator. So here's an example of a polynomial, 2x squared plus 6x minus 9. I have 3 different terms, 1 term, 2 terms, 3 different terms there. Okay, negative x cubed plus 9. I have 1 term right here, negative 1 times x cubed, and my other term is positive 9 right there. This last guy, when I look at it, I have 1, 2, 3, 4, 5 terms. Okay, so each one of these has a variable that has a positive whole number exponent. Things that are not polynomials, if I look here and I have 10x to the negative 1, that has a negative exponent, so it's not negative exponent. It's not a polynomial, it's just not the name for it, it's something else, okay? Square root of x minus 2, a square root, if you remember, it's really x to the 1/2, and so it's because of the square root that makes that not a polynomial. It's something else, it's still math, it's just not a polynomial. This guy, 3 over x plus 5, this is a variable in the denominator that makes it a denominator. That's what makes it not a polynomial. Still, again, it's math that we can do, but it's just not, these things are not called polynomials. All right. So think back to Unit 4. We talked about different forms of equations, and you'll remember that we had a standard form of an equation. In this case, we are thinking of how we write out our polynomials. We're also going to call this standard form, but in this case, it's when all of our like terms are combined, so there's no more math to do, right? And the terms are written in alphabetical order, with the highest exponent first. Okay, so I'll show you some examples of this. There are some additional rules when you have more than one variable in the same term, but we're going to just stick with this basic definition for right now. Okay, degree of a polynomial. The highest degree or exponent of any one of the terms is your degree. Okay, so I'm just going to look at all of my terms and I'm going to look for the highest exponent that I can see. So up here, for example, 5x squared plus 2y minus 7. This has an exponent of 2. This has an exponent of 1. And of course, all of my constants just have an invisible exponent of 1, right? So the degree of this guy would be 2. Again, the degree of this one would be 2, because at best I have x squared. This one, the degree is 3, because that's the highest exponent I have. And down here at this big long polynomial, I have something to the 4th power, so my degree here would be 4. Okay, so that's all you're going to do. If you need the degree of the whole polynomial, you're just looking for the biggest exponent that you can find. All right? It's going to help you determine the number of solutions you have, especially once you're in Algebra 2. So we're just going to practice using that terminology right now, mostly. Okay. You know the word coefficient. The coefficient is the number that is multiplied with a variable. And so up here, 5x cubed, my coefficient is 5. Right here, negative 8x squared, my coefficient is negative 8. Okay, because I am subtracting 8x squared or I'm adding negative 8x squared. So negative 8 is my coefficient there. All right. This is new. So a leading coefficient. This is new to us. When a polynomial is written in standard form, the leading coefficient is just the coefficient of that very first term. So remember, when we're putting it in standard form, we're going to have it be alphabetical order, and the highest exponent is going to be first in the first term. So whatever that coefficient is in that first term is going to be your leading coefficient. All right, so it sounds a little bit odd, but monomial is just one single term. We still call it a polynomial. Okay, so it is a specific polynomial that has only one term. So mono 1. Binomial, mono is 1. Binomial, of course, is 2, so it's some sort of a polynomial expression that has 2 terms. And then a trinomial, you might guess, is going to be a polynomial expression that has 3 terms. Okay, so a lot of vocabulary to work with here, but we'll try to keep using it and get you practiced up. All right, if I want to write each one of these polynomials in standard form, we said that our standard form, right at the top here, is a polynomial that is written in alphabetical order with the highest exponent first. So I got to look here. I only have the variable x, so luckily I don't have to worry about alphabetical order. But this is my highest exponent right here, right? So my term is positive 2x squared. So I'm going to start with that. And then I'm going in descending order. This is 3x to the 1, right? So I'm going to say that's plus 3x. And then I follow it up with just my constant 1. As a side note, you can imagine that 1 is really 1 times x to the 0, right? Because x to the 0 is just 1. And so I have x squared, x to the 1, and now x to the 0, if I really wanted to think about how that happened. So all of my variables there would be to the power of 0, which is why they're not there. All right, number 2, we're going to put it in standard form. So it also has to be all the way combined, right? We're not going to make anybody do any math if there's any combining of like terms that can happen. K squared plus 64 minus k plus 7k cubed. Nothing can be combined, so I'm going to look for my highest exponent. And so this is my term, 7k3, that has the highest exponent. And then I'm going to take k squared, and I'm adding it, because that k squared is positive. Minus k, do not lose your negative, okay? This is minus k. That negative or subtraction sign is glued to that k. And then plus 64. So now I'm in the right order. I'm only one single variable, so I didn't have to worry about alphabetical order, but I'm going in descending order. I'm getting smaller with my exponents. And just as a reminder about some of our vocabulary, leading coefficient, remember it's just the coefficient of the first term. This leading coefficient is 2. Leading coefficient is 7. Okay, if you want to try 3, 4, 5, 6 on your own, you can, and then just check back, so you could pause the video, or I'm just going to do these right now as well. I don't care what my coefficients are when I'm first putting this in the order I want it to be. I only care about the exponents. So this is my highest exponent right here, so that's going to be first, w to the 3, and then my next one down is w squared. Then I need negative w. Remember that negative is glued to that w, don't lose it, okay? And then plus 28. Okay, I'm going to double check. I am in alphabetical order because I only had one letter to deal with, and then I'm in highest exponent here, and then I'm descending. Okay, number 4. It's completely out of order, and I need to be careful. This is negative n cubed. So I'm going to say that's negative n cubed. And then I don't have an n squared, so that's okay. I'm just going to look at my next option is just n. And then finally, I have a positive 24. Okay, so my final response here is negative n cubed plus n plus 24. I'm in alphabetical order because there was only one letter. and I am in descending order on those exponents. Also, just as a side, that leading coefficient would be -1, right? Okay, let's look at all of this. None of these are like terms, and so I can go ahead and I'm going to go alphabetical. So this time I do have A's and B's. So I'm going to say A cubed is my first term there. So since I have more than one variable, I'm going to tell you there are different ways to think about this. I'm going to deal with my A's. That's my first letter in the alphabet of the letters that show up in my expression. So I'm just going to work with my terms, and I'm going to go in descending order with the variable A. Okay, so I have just A cubed right here, right? And then here I have A squared in that term, okay? So I'm going to put this one next because I'm going descending from the A. So A cubed is first. Now I'm going to add 5A squared B squared, okay? Then I'm looking, my next A is this guy right here. So maybe I'll rectangle it. So I just have A to the first power. So I'm going to say that's plus 2AB. And then the only one I didn't deal with yet is this guy. So I'm going to say minus 2B cubed. Okay, so this is in descending order by A. Descending A exponents. Exponents. Okay, just so you know, descending A exponents. And I chose A because it was first alphabetically. So on number 6 here, C and D, the first thing alphabetical is C, right? Remember this negative is glued. That's really -1C cubed. So I'm going to start with that, -C cubed. Then I'm going to look, is there a C squared? Sure enough, there is. So I'm going to say minus 7C squared, D squared. So I'm just taking that term, right? And then I don't have any more C's. So I'm going to grab this 5D cubed. And plus 13 is my last thing. Okay, so this is C is descending, so I'll write it the same way. Descending C exponents. And then the variable D. Okay, so if I had had anything else like D squared, that would have gone after D cubed. Okay, excuse me. Let's take a look. So now we are going to think about classifying each one of these polynomials by its degree and by its number of terms. So remember degree, we're just going to look at all of the terms, and whatever the highest exponent is, that's going to be our degree. Okay? The number of terms, remember that's when we were talking about whether something's a monomial or a binomial or a trinomial. So does it have one term or two terms or three terms? If it has more than that, we're just going to say it's a polynomial. We're not going to be all crazy, okay? But we have some more specific things that we, more specific words that we use when we're talking about how many terms. Because we're going to look at, well, we're going to look at a bunch of things. All right, so classifying by degree, we're going to think about what is the number of our degree. What is the highest exponent that we have? Okay, when we have a number like 6, who knows what the variable was, but it was probably, it might have been x. Whatever it was to the 0. It might have been 6a to the 0, who knows? But the degree is 0, see that? Okay, if our degree is 0, notice we just have 6. There's no variable at all. If the degree is 0, your expression, you just have a constant. If your degree is 1, that's an invisible 1, right? If your degree is 1, you know, if I put that on a graph, y equals -2x, you guys know that would turn into a straight line, right? So we know that's linear. Okay. We also know it has a slope of -2, so we know it's going downhill if we want to write that out as a graph, right? Okay, something like this, 7p plus 1. This one has a degree of 1. That's my highest degree, right? Okay, so I'm just looking at degrees for just a moment. This guy, v squared plus 2v minus 5, v squared, I know that if I were to graph that, it's going to make a quadratic equation. And so I'm going to write the word quadratic. Be careful here because I know quad normally means 4 to us, but it's actually a different derivation. So quadratic, we are talking about having something squared. Okay, if I have an exponent with a 3, so I'm now just following my degrees, okay? This is degree 3. This polynomial has third degree, right? You know that if you have 3 dimensions, like a box, it's cubic, right? So if I have a highest degree is 3, I'm going to have a cubic statement. And then finally, if my highest degree is 4, here's our fancy word. This, so not quadratic, but we are going to call it quartic. Quartic. Okay, quartic means 4. All right. So now I have to classify each one of these polynomials here, not only by its degree, but also by its number of terms. So we know this guy, 6, has a degree of 0. Okay. Also, I want to know how many terms does it have? Well, it only has 1 term, right? So I'm going to say it's a constant, since its degree is 0, but it's also a monomial, because there's only 1 term, okay? So if we only have 1 term, it's a monomial. This guy, also only 1 term, right? Only 1 term. So I know it's a monomial, because it's only 1 term. But this time, my degree is 1. So I'm going to look on my list. Oh yeah, that's linear. Remember, that makes a line. So it's going to be a linear monomial. So we're figuring out what is the special word that we use for the degree, and we're also figuring out what is the word that we use to describe the number of terms. Okay, so I'm going to pause for a second because we know if I have 2 terms, it's going to be a binomial. If I have 3 terms, it's a trinomial. And here's where I don't get any more fancy than that. Anything 4 or greater, we're just going to say is a polynomial. There you go. Okay, so let's come back up here. I have 1, 2. I have 2 terms. 2 terms means it's some sort of a binomial. So now I need to look at my degree. This is a degree of 1. Remember, that was just 7p plus 1. So a degree of 1 just makes it linear. If I graph that, y equals 7p plus 1, it's going to be a straight line, right? That crosses through that y-axis at 1 with a slope of 7. Okay, this guy, 1, 2, 3, it's a trinomial. What kind of a trinomial? Well, let's look at the degree. The degree is 2. It's quadratic, so you just need to remind yourself that it is quadratic when it's 2. That's actually our quadratic. That's our next unit after polynomials is quadratics. Okay, 1, 2, 3, 4. I have 4 terms, so I'm just going to call this a polynomial. And now I have to think about that degree. That's the one that's 4, so I would want it to be quadratic, but it's not because 4 is special. It's quartic. Quartic. Okay, and then finally 1, 2, 2 terms, so it's binomial. What's my highest degree? 3. So it's a cube. It's cubic. Whoops, sorry. I need to say cubic. Pretend I wrote cubic instead of cube. Okay. All right, so we are just going to do a little bit of review here for these next couple of problems. We were thinking about those like terms. Remember combining like terms earlier in this year or in this whole course. So when we want to add and subtract polynomials, we have to first make sure that they have exactly the same variable or variable combination, and that variable has to be raised to the same exact power, or else we can't combine them. Other things we have to do, we have to follow order of operations. So if we have parentheses, we need to make sure that we do any math that has to happen throughout those parentheses. So sometimes that's distributing a number, sometimes it's distributing a negative sign, or you can think of it as -1. If I'm adding 2 different expressions, I don't really need parentheses. So this is negative 3x minus 4 plus 2x plus 6. Since I'm adding, I don't have to worry about those parentheses at all. I'm going to look for like terms. So I have negative 3x that I'm going to combine with 2x. Negative 3x and 2x is just negative 1x, but I'm going to write it like that. Okay, and then other like terms, constants are like terms. So I'm going to combine this negative 4 and positive 6, which is going to give me 2. That's it. I've combined those like terms, and that's what I've got. Okay, over here, again, I have an expression in parentheses added to an expression in parentheses. Since I'm adding, there's no math to do across those parentheses, so I'm just going to find like terms. So I usually start at the left, and after I have combined like terms, then I double check and make sure I am in the order that I want to be for standard form. So 3y squared, another like term would be 7y squared. It's positive because I'm just adding a positive 7y squared. So 3y squared and 7y squared, 3y squared plus 7y squared. It's going to be 10 squared, right? It's not. It's going to be 10y squared, sorry. Okay, then I'm going to do 5y and, whoops, no other y's. So I'm just going to add 5y because there was nothing to combine it with. And then I'm going to do negative 6 and negative 9. So that's going to be negative 15. Okay, I'm looking to make sure I am in order of alphabetical. There's only one variable, right? And then the highest degree going down. So that's going to be my final answer there. Okay, I forgot. This also says classify the polynomials. So let me come back to this first one. Okay, it's 1, 2. It's 2 terms, so it's going to be a binomial. And I want to look at the degree. The degree is 1. So remember, if I just had y equals negative x plus 2, if I plotted that on a graph, it's going to be a line. So I'm going to say that's linear. Okay. This guy, 10y squared plus 5y minus 15, it's a trinomial. There are 3 terms. And I look at my highest exponent, so 2 right there. So I'm going to call this quadratic. Okay. Quadratic means you have an exponent of 2. All right, here, this expression plus that expression, I'm still just adding. So I don't have to worry about the parentheses because I'm just combining like terms for real here. Okay, also notice when we're going to classify our polynomials based on their degree and the number of terms, I have to make sure I'm all the way simplified. I can't look at this and say 1, 2, 3, 4, 5, 6. I can't say that it has 6 terms because I haven't combined stuff yet, just so you know. Okay, so I'm going to look for like terms. I have an x squared and I have 6x squared. So 1x squared plus 6 more x squareds is 7x squared. I have negative x, and then I have positive 2x. Don't lose your negatives. So negative x and positive 2x is just positive x. And then I have positive 5, and negative 10 is going to be negative 5. 1, 2, 3. I have a trinomial. And my biggest exponent was 2, so that is quadratic. So this will be second nature to you, hopefully, you know, as we keep practicing these. But for now, you can look back at that chart. Okay. So I have, this time, this expression minus everything in that expression. Okay, this is the same as saying plus negative 1 times all of that. I need to distribute that negative. I'm subtracting 2x squared, but I'm also subtracting 4x, and I'm also subtracting negative x. So we are distributing a negative to all of the terms in that expression. So I'm going to keep x squared minus 4 the same, and now I'm saying minus 2x squared, minus 4x, and then minus negative 6. When I subtract a negative, I'm really adding a positive. Okay, look for like terms. So I've got x squared, and I've got negative 2x squared. So I have negative x squared, and then I have negative 4x, and no other x's, so that's just minus 4x. And then 6 minus 4 is 2, positive 2. All right, 1, 2, 3. It's a trinomial. We're going to use a lot of trinomials this time. Trinomial. And my highest degree was 2, and so I'm going to say it's quadratic. All right. Again, I am subtracting, so I'm going to distribute those negatives all across. I can bring the first expression down because I'm just adding everything here to the other stuff. So I'm going to say this is 6x squared plus 4x minus 2. And now I'm subtracting 3x squared. I'm subtracting negative 2x, so that's really adding 2x. And I'm subtracting 7. So let's combine like terms. I have 6x squared and negative 3x squared, so I have 3x squareds left. I have 4x and 2x, so that's 6x. And then I have negative 2 and negative 7, so that's minus 9. 1, 2, 3, 3 terms, so it's a trinomial. Oh, you can't see any of that. I'm so sorry. Is this okay? I brought down 6x squared plus 4x minus 2. Forgive me for that. And then I'm subtracting 3x squared, so it's minus 3x squared. I'm subtracting negative 2x, so it's plus 2x. And I'm subtracting 7. So sorry. 6x squared minus 3x squared is 3x squared. I found 4x and 2x. Those go together, and they're 6x's. And then I have negative 2, and negative 7 is negative 9. So I know it's a trinomial. And my highest degree is 2, so it is quadratic, which is Unit 8 for us. Quadratic. It's a quadratic trinomial. All right, one more time, and maybe try this one on your own and pause and then come back. Distributing that negative, I have 5x squared minus 9x plus 11 minus negative 2x squared, so that's really plus 2x squared, minus 3x plus 2. I'm going to combine like terms as soon as I find them. So I have positive 5x squared, and I have 2x squared, also positive, right? So 5 and 2 is 7. I have 7x squareds. I have negative 9x, and I have negative 3x, so minus 12x. And then I have 11 and 2. This is a trinomial, and again, degree is 2, so it's a quadratic trinomial. Okay, great. I'll do the rest of these problems on a second video just because this got sort of long, but thank you so much for watching.